Hello my dears, very good morning to all. So today we are going to discuss about CRO, that is Cathode Ray Oscilloscope. What is that? Cathode Ray Oscilloscope. So this is the constructional diagram. So no one will ask you what is the constructional diagram and all in your examination, but some points are there. So from that, theory questions you may expect. What is that? Theory questions you may expect. Let's see. So CRO, the best example of this CRO and all is like our old CRT monitor TV. Did you see that? Old television. Did you see that? So that shape itself like a funnel, funnel like structure. Suppose you repair, during the repairing of that TV, did you notice one thing? That is a funnel shape, right? So that is exactly what the CRT or CRO means. Okay, that CR oscilloscope means that CRT is utilized to measure some signal is called cathode ray oscilloscope. The basic thing is it simply CRT, that's all. The television, the screen television, right? The screen of the television now, that is called a CRT. That is why the name CRT monitor. Did you heard that name? CRT monitor. So basically it consists of, see, let's start from this end. This end consists of a heating element. The function of the heating element, in order to produce the electrons, it is used to produce the electrons by the process called thermionic emissions. What was the name? Thermionic emissions. So these are the words, words you have to note. So that question may be asked from this region. So this is called the thermionic emission, and this is the heating element which require a voltage of 6.3 volt to 600 millivolt. 6.3 volt to 600 millivolt. Okay, and at the tip of this heating element, my dears, there is a cathode. The cathode is used to emit the electrons. The cathode is used to emit the electrons. So the cathode is nothing but barium oxide or strontium oxide. Barium oxide or strontium oxide, that is BaO or SRO. The function of the cathode is to what? Emit electron. How it is emit electrons? No, it is heated up in its back by heating element. So something it is heating, if it is plenty of electron, if it have a plenty of electron, then it will emit heat definitely. They will emit electron definitely. So this cathode will what? Emit electron. And this cathode randomly emit electrons. Now it is emit electrons in all its 360 degree surrounding. It emits electrons. Suppose this is the cathode strip, means it emits here, it emits here, it emits here. Likewise, no, 360 degree of its periphery, it will emit electrons. So we have to collect that electrons and combine to form a beam-like structure. Combine to form a beam-like structure. For that, we are using grid. So physical meaning of grid is what? Suppose we are moving into the grid, means we are attaining a particular shape. That is the meaning of grid. So this electrons, right? This randomly oriented electrons emitted by the heating element, which is 6.3 volt, 600 millivolt ampere. 6.3 volt and 600 milliampere. It will emit electron, and it is 600 milliampere. Okay, correct. It's not millivolt, milliampere. 6.3 volt and 600 milliampere. Okay. So this grid is made up of nickel, and the grid, you know, my dears, this is more negative than the cathode. It is more negative than cathode means this is also the grid also negative potential. The grid also in negative potential. Negative charge nickel is called the grid. So this is also a negative potential, right? So what it will do? See, this electron having a negative charge. You know that this electron having a negative charge. So what the grid will do? negative charged electrons actually opposed by the grid. Now, the negatively charged electrons are opposed by the grid now. So what the grid do? The randomly oriented electrons are there around its vicinity or around its peripheral. So what it will do? It will oppose the electrons. Then only it will form a grid-like structure. Suppose it attract means it will like that, no, that will consider. So it opposes the electron. That is more negative than the cathode, so that the electron will be beamed into a particular structure, a beam-like structure will obtain. That means simply, my dears, the electrons are like this, say the randomly oriented electrons. So what it will do means it will form a beam-like structure. That's all. It will form a beam-like structure. Okay. So after the grid, the electron form the beam-like structure. So after that, the speed will be reduced, right? So what it will do? We are using pre-accelerating anode. So this is the pre-acceleration anode. So what it will do means it will speed up the what? Speed up the electron. It will speed up the electron, and again it comes to the focusing anode. The focusing anode means, my dear, the function of the focusing anode is that it will do? It will focusing the beam to a dot. So this is the beam. So it will convert this beam into a dot, finally a dot. It will convert this beam into finally a dot-like structure. Is the function of the focusing anode. Focus means a particular point, that's all. Focus means a particular point. So it will convert what? The focusing anode will convert what, my dear? It will arrange the beam into a particular focus or a particular beam. Okay. So what focusing anode do? It will make the entire beam into a dot-like structure. This dot-like structure now, this is actually due to the astigmatism of our ID. Astigmatism. It is due to the astigmatism of our eye, which means we feel like it is a dot. It is not actually a dot, it is a beam-like structure, but a pointed beam-like structure. So to our eyes, it is feel like a dot. This is due to the astigmatism. Okay, and next is what? Focusing anode, and next is the post-acceleration anode. It also do the same function as the pre-accelerating anode, my dears. So what it will do? It will again increasing the speed. It will again increasing the speed of a single dot, and it will reach either in the vertical. It will reach here. So it will be attracted by the vertical deflection plate as well as the horizontal deflection plate. So due to the attraction, it will deflect towards a vertical deflection plate, or it will deflect towards horizontal deflection plate, and finally it correct meaning it means yes, it projected, actually it throw or it projected on the screen. It is a phosphorus screen. So what it will do? It will glow the beam, right? It will glow the incoming beam. Now see the phosphorus light here. If you touch there, it will like a glow. So that glow will be there on the screen. So, and you may have a doubt that what are these? I will tell you. See, during the movement, right? During the movement of this electron, some of the electron may hit here also, because this is the vertical deflection plane and this is the horizontal deflection plate. So what is the function of this vertical and horizontal deflection plate? I will tell you. Suppose this is the sinusoidal quantity you want to see. Suppose this is the sinusoidal quantity you want to see on the screen. So the sinusoidal signal having both the vertical side movement as well as the horizontal side movement. It is not only the vertical side movement in the signal, it is also a vertical side as well as the horizontal side. If it is a vertical signal, means like it will like to be here. It is a horizontal signal, it will be like here. But it is not that both the horizontal as well as vertical movement is there regarding the sine wave. So what we have to do? At this, consider this point, my dear. This point, the vertical component is there and horizontal component is there, both having different value. So this difference now, this different value now, this is goes to the vertical deflection plate. So it is called a vertical deflection plate. It's same. And this point now, this is goes to horizontal deflection plate. This having a value, suppose let it be 5, and this having a value let it be 2. So 5 is more strengthier than 2 now. So this vertical deflection plate offer a 5 volt strength signal to attract the electrons in 5 volt manner. At the same time, the horizontal deflection plate will apply a signal of 2 volt nature, so that this 5 and 2 volt difference now, that will tend to deflect the electrons not fully horizontally, not fully vertically, not fully horizontally, but a slight deviation like structure. A slight movement will be there, not fully vertical, not fully horizontal, but a slight movement will be there to the electron, so that slight movement will be projected, or it will fired like a bullet, like fired into the screen. So a dot will be there into the screen due to the deflection. This is very rapidly occurring process, right? This is very rapidly occurring process. So at the next instance, see, at this next instance, this is 6 and this may be 3. So what happened? This vertical deflection will drag the electron according to its 6 volt capacity, and the horizontal deflection will again drag the electrons 3 volt capacity. So in effective, the electrons will be projected like, suppose it is projected on the screen, suppose this is the screen, initially it projected here means it will project like here. So in short, my dears, in short, in the screen, on the screen, what you see, this like structure you see, this like structure you see due to the what, deflection plates, due to the what, potentials of deflection plates. So if the dots are too closer, that means if this happens in very rapid manner, if the dots are seems to be very closer and closer, and added with our astigmatism, it will feel like sine wave. It will feel like a sine wave. So that is the simple working of what, our cathode ray oscilloscope. Okay, and again come to the point. One more thing, see, here it is aquadag coating. Aquadag coating, and here we see very thin metal of aluminum. What is the function? I will tell you. So due to the deflection, this is the cream. So it may not be reached directly here now. So due to this movement, it may hit the surface of very thin aluminum frame also. And what happens, my dear? This aluminum frame now, it contains abundance of electron. So due to the bombardment of these electron to this aluminum film, it again emit some more electrons. So it is called the secondary emission. It is called the secondary emission. So due to the secondary emission, a portion of the other, that means the electrons now, electrons bombard with this aluminum. So this aluminum also absorbs some electron. It is called a secondary absorption, and it will again emit some more electrons. See, suppose you throw a ball or some small paper balls into the water. Some of it will be absorbed rapidly, but some of it will reject back now. So same thing will happen here also. So some will be absorbed here and some will be rejected from here. Some electron will be ejected from here. That absorption is called a secondary absorption. That emission is called a secondary emission. Meanwhile, that means anyhow, the absorbed electrons are less compared to the ejected electrons from the aluminum. So that more number of electrons will be created. More number of electrons will be created, and those extra electrons now, those extra electrons, right, those extra electrons which is deviated from its path, it will be absorbed by this aquadag coating. It is actually aqueous solution of graphite. It is actually the aqueous solution of graphite, and it will be absorbed by that it is deviating electrons now, that will absorbed by that aqueous aquadag coating, and rest of the electrons, which is very powerful in nature, will combine with these electrons and forcefully it will hit on the surface of the screen, and finally a bright or intense the sine wave will be shown in the screen. Okay, so that is the function. So in examination point of view, my dears, the things you are supposed to ask is what will be the voltage and current rating of this heating element. That will be asked. It is 6.3 volt and 600 milliampere range. And what is the order of the below 3? It is pre-accelerating, focusing and post-acceleration. This order will be asked. What is first? From here also you may expect grid, pre-accelerating, focusing and post-accelerating anodes. This also you can see. So what is grid? Grid is a cathode which is more negative than the heating element, or this cathode, barium. Or what is the material that is made up of? Barium oxide or strontium oxide is used as the cathode. Or what is the function of the aquadag coating? In order to, it will absorb the extra electrons emitted by this thin aluminium plate. Okay, so these are the questions you may expect from here. Working and all, no one will ask you, so don't focus too much on the working and all, just you have an idea. Okay, and it is like, my dear, see, I will tell you a very good example. Suppose I have a gun in my hand. How that sine wave seen on the screen? Now you have a doubt now. Suppose I have screen. Suppose I am making fire, or I make fire like tick 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 tick, and I am making a sine wave like structure. The same thing will be happen here. The vertical and horizontal deflection plate are like my hands. It will control the electron gun. It will control the electron gun in order to make a sine wave. So tick 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 tick, a like sine wave like structure will be created on the screen. Simple working principle. A simple principle, my dears. So in order to make it a sine wave, suppose I am moving my hand only in this direction. In this direction, I will only get a vertical line. It is not a sine wave. Suppose my hand movement is like this, I will only get a horizontal line. This is also not a sine wave. Suppose I can move like this and this, I can create a sine wave. So that is why like the structure. So that is the principle behind the vertical and horizontal deflection plate. Okay, is it funny? I know, but no, we have to study. Anyway, we have to study, right? So that is the working of CRO. And here you can see another diagram. See, my dears, the entire circuit it needs different level of voltages. For CRT, cathode ray tube, this vertical deflection plate and horizontal deflection plate and all, it requires a very high voltage. So it is provided by a high voltage supply. And other electronic equipments see like our cathode, vertical deflecting amplifier, this pre-accelerating anode, post-accelerating anode, focusing anode and all, it requires not that much voltage level. So it requires only a small voltage level. So that is provided by LV, that is low voltage supply. And how this is exactly working, I will tell you. Suppose our signal, my dear, our signal, suppose this is a signal. Our signal is given to the vertical amplifier first. Vertical amplifier. Inside this, there will be a vertical amplifier that is controlling the vertical deflection plate. Okay. That signal is directly given to the vertical amplifier. When the signal is given to the vertical amplifier, suddenly it will give a signal to the trigger circuit, my dear. Trigger circuit. A signal to the trigger circuit. And this trigger circuit is nothing but the trigger will be in the form of a spike. So this will convert into a sawtooth waveform, and this is given to a horizontal amplifier. This is HA means horizontal amplifier. In order to strengthen or in order to amplify the sweep waveform, it will give to a horizontal amplifier and it will give to CRT. Why this step is needed here? The function of the horizontal amplifier and the horizontal amplifier here, or the horizontal deflection plate here, it is directly given to, you can write like this, my dear, horizontal deflection plate, and then it is given to CRT. The function of horizontal deflection plate and horizontal amplifier and along with the sweep generator and all is to produce simply the time base, my dear, time base. Because for every signal it is to be represented on the screen, first you need a time base. Okay, and that time base now, that time base will be much earlier than the signal arrived. For example, if you are tracing a signal of what lightning, suppose you are tracing a signal of lightning, this can be traced by using CRO. Suppose you are tracing the lightning, suppose the lightning the lightning may be there, no, maybe in the atmosphere for maximum 1 or 2 or 60 microseconds or 100 microseconds maximum. Within that time it will vanish. So what you have to confirm before that observation is that you have to generate a time base before that. A time base will be there, then only that signal can be projected into the graph. Otherwise we can't plot the signal. If there is no time wave, there is no time base, then how can we analyze the signal? Or how can we know that that signal existed for this much time? How can we know that? We can't predict now. So the function of this entire circuit is to produce the time base bus. And definitely there will be one more thing, is there will be a delay circuit. There will be a delay circuit inside. It is not actually seen here. That delay circuit, now my dear, it is always delayed the signal to some more extent, and only after the time base is generated here, the signal will be applied to vertical deflection place. So you can mark here as a delay line. A delay line is also like there. So this delay line will create the signal. Now the signal is waiting for certain time. After that is applied to vertical deflection. So during that signal waiting, already a time base will be generated behind, I mean in that time, that delay time, but a time base will be generated here, so that a time base will be there. And after that, if you have a signal like this or this, you can draw, you can study anything, you can study only after creating a time base. Only after creating a signal. Suppose you have a lightning straight or lightning signal. This is a random signal, my dears. Suppose you have lightning signal, it will be like this, lightning signal. So unless the time base is there, we can't trace the signal. So for that we are using the entire circuitry. So it is inside this CRO, the circuitry, and that's all. Is it clear, my dear? So the function of the horizontal amplifier and vertical amplifier, horizontal deflection, vertical deflection plate, all clear now, right? All clear. So the main thing is you have to generate the time base first, then only we have to mark the signal or trace the signal on the screen. Clear? So that's all, my dear. If you really want to know more and more, you can Google it and you will find. Okay, the theory, it's just a theory. You can speak for a very long time, it's theory. So that's all. Examination point of view, it is much more. Okay. Okay. Next one. And one more thing, this CRO, for AC, it shows maximum or peak to peak value. Okay. RMS value later only we can calculate, like Vrms equal to Vf by root. See, in the CRNO, my dear, it will only give the peak to peak value. You already know this because in your electronics laboratory and all, you did this experiment. And the teacher asked, what is the peak value? This, not the RMS value you asked, right? Only you can ask the peak to peak value. So from the peak to peak value, that is the Vm or Im, you can calculate the RMS value later by calculation and not directly. And for DC, my dear, for DC, you will directly get the value, right? A direct value you obtain. Direct value you obtained, right? For DC, direct value you obtained, and direct value obtained. For AC, you will get the peak to peak value, okay, not the RMS value. That also you cannot. And where it can be applied with applications. What are the applications? Radar, TV, and what? Analyzing signals, analyzing signals, and calculation of alpha, beta, gamma of a transistor, and again BH curve, study of BH curve, etc. There are the areas where you can apply this, okay. That's all about the application and all. Next, deflection sensitivity. Deflection sensitivity was here. There is an equation made here. LLD divided by 2DDA meter. That is the deflection produced by both the horizontal as well as the deflection or vertical deflection plate. The average deflection produced by, which is nothing, my dears, there is no deflection means the beam is moving like this. If it is moving like this means this is the deflection. If it is moving like this means this is the deflection. So the average deflection produced by the deflection plates is given by L into LD ED divided by 2D EA, where D is the deflection and L is the length of between center of plates to screen LD distance between deflecting plates and distance between deflecting plates and ED, deflecting potential, or simply the voltage applied, my dear, that's all. And small d, length of plate, and EA, accelerating potential. Because we are using accelerating anode now, so it requires certain voltage now. That also what depending the entire projections on the screen by the electron. So that also is depending factor. So from this, D by ED is called the sensitivity. D by ED is called the sensitivity, and its unit is meter per volts. Unit is meter per volts or mm per volts. That is the correct. Mm per millimeter per volts. Millimeter per volts. From this D by ED na LLD divided by 2D EA, that is called the sensitivity. Only you just remember this equation. Only this equation you just remember. Maybe what are the factors affecting the deflection? You may expect a question like this. Suppose the length is increased, then the deflection increased. The ED deflection potential is increased, the deflection increased. Suppose that this is the D. D means distance between the plates, length of the plates, length of the plates. So length of the plate, suppose you increased, the deflection decreased. So like that you may expect some questions. So that's all for the deflection sensitivity of CRO. Okay, just remember this equation and this what abbreviations LLD, ED, and all. Okay, so that's it. Is it clear? Next is Lissajous pattern. Very, very important, my dears. Very, very, very important. Lissajous pattern is nothing but certain pattern you are seeing on the CRO. From that you can find or you can analyze the signal. That's all. You can analyze the nature of the signal. That's all. So there are two types of or two conditions are there. First condition, frequency is same and phase angle difference. For example, suppose you are giving a signal to the vertical deflection plate, horizontal deflection plate. It is represented by VH, shall be VH, horizontal deflection plate is represented by VH, and that is nothing but, my dear, suppose A sin omega t, and you are giving another signal to the vertical deflection plate, that will be VV, which is nothing but A sin of omega t minus pi by 2. See, suppose you have to analyze these two signals. You don't know the phase angle and all, right? You don't know the phase angle and all. You simply give two signals to the vertical as well as the horizontal deflection plate, and something you see on the CRO. Something you see on the CRO, and by looking at CRO image, you can predict the phase angle. You can predict the phase angle. The condition is that frequencies are same. The two signal frequencies are same. Suppose you have two signal in your hand, the signals frequencies are same, and you don't know the phase angle delay or the phase angle between those two. Okay, give it to the CRO. Give it to CROs, but horizontal one is for horizontal deflection phase and other is for vertical deflection phase, and you will get some pattern. I will explain what are the patterns and all for different phase angle, and you can easily say what is the phase angle between that two signal. That's all. You can easily predict the phase angle between the signal. Okay. Okay. Is it clear, my dear? Is it clear? So let us see what are the traces. For 0 degree phase angle or 180, so 360 degree phase angle, this will be the trace. Vx and Vy. Or simply x in graph, simply x axis and y axis only. Okay. In x axis and y graph axis, this is the 0 degree or 360 degree, both are same. This is the trace. Suppose if you give two signal and if you found in the graph in this manner, you can say that okay, the horizontal deflection plate signal with respect to that, the vertical deflection plate signal is 0 degree or 360 degree lag, or they are in phase. Simple. They are in phase. Simple. Suppose this is the trace you found. then you can say that it is 180 degree. And those two signals are what? 180 degree, if this is a way. Okay, so 0 is there and 180 is there. Okay, next, suppose in this way you are seeing, and the arrow is also there like this, and this is for 90 degree, this is for 90 degree, and suppose you are seeing like this, anti-clockwise, this is for 270 degree. Okay, and suppose an ellipse like structure you are seeing, it is nothing but 45 degree ellipse. Suppose the same ellipse is like this, so this is 135 degree. Okay, 135 degree. And except for, and mark one point also, except 0, 180, 90, 270, 360, all angle results an ellipse on the screen. This you have to note. Except this 0, 360 or 180 or 90, 0, 360, 180 or 90 or 270, 270, okay. All other, suppose you are giving 183, it will form an ellipse. Suppose you are giving 47, suppose the phase angle between those two is 47, then also you will get an ellipse. Then also you will get an ellipse. So generally these will be the angles asked for your examination. So you have to by heart these structures. You have to by heart these structures. Condition, so only condition 1 you draw. But what is the condition? What is the condition, my dear? The signal frequency is same, but the phase angle, or there will be a lagging or leading between the what? Signals. Then you can find by simply looking into the graph, you can find how much will be the phase angle between those two signals. How much will be the phase angle between those two signals, you can find. Is it clear? You have to by heart, my dear. You have to by heart these 1, 2, 3, 4, 5, 6 figures. Bus. Definitely a question will be asked. If the question paper is superb and very good, definitely you will expect a question from Lissajous pattern. So in measurement, this is the most important session, my dears. This is the most important session. Lissajous pattern. Okay. And next, condition 2. Condition 2. So this is condition 1. Next, condition 2. Condition 2, so second condition. Second condition is that, but the opposite case. Frequency different and same phase angle. Then what will be? Then what will be? So for that, my dear, you have an equation. That is fx by fy is equal to vertical tangency by horizontal tangency. I will explain what it is. Okay, I will explain what is it. Fx by fy is nothing but, my dear, the signal applied to the horizontal deflection plate frequency is fx, and the signal applied to the vertical deflection plate frequency is fy. That means one signal and another signal. Okay, horizontal deflection plate signal and vertical deflection plate signal, that's all. Which is equal to opposite, vertical tangency by horizontal tangency. I will tell you what it is. Just write an example, my dear. I will tell you what is the vertical and horizontal tangency is. A simple example first. Listen, my dear. So, vertical tangency means here fx by fy will be equal to, that is the ratio of the frequency horizontal and vertical will be equal to, first vertical tangency divided by horizontal tangency. Let's see what is vertical tangency. Vertical tangency means, my dears, the vertical axis now, how many times it touches the vertical axis, that's all. How many times it touches the vertical axis called the vertical tangency. Okay? Okay? So only one time it touches the sphere. Now this is a sphere. The circle only touches one time to the vertical axis. So the vertical tangency is simply 1 divided by horizontal tangency means how many times the sphere or this circle touches the horizontal scale or horizontal axis. 1, 2. So it will be 1 by 2. And in question, any one of the frequencies given. Suppose fx you already given like 10 hertz. Then what will be fy? Suppose it is 10 hertz divided by fy will be equal to 1 by 2. So simply fy will be equal to what? 10 into 2. That is 20 hertz. So like that you can find the frequency like that. So like that you can find the unknown frequency. So condition frequencies are different. So that difference frequency we have to find same phase angle. So we are not bothered about that. So we are bothered about we have to find the frequencies. That's all. So that is our aim. Okay. By UD we will do some more problems regarding this now. So definitely it will be clear. Okay. So we will do problems. We will do problems. These also you may expect. These questions also you may expect. Write a question, my dears. So patterns, the patterns means this circle like a structure you can see on the screen. So from that screen you can find the frequency. That is the meaning of pattern. Okay. So write a question. Suppose you are seeing the Lissajous pattern as so what is, suppose fx equal to 10 hertz, fy will be what? This is our question. How can we solve? How can we solve? Listen. So first of all, we have the general equation of fx by fy is equal to vertical tangency divided by horizontal tangency. Vertical tangency divided by horizontal tangency, which means vertical tangency means how many times the circle touches the vertical graph. That is the vertical tangency. How many times the circle touches the vertical line. So only one time it touches the vertical line. Only one time it touches the vertical line at this point. So this is 1 divided by horizontal tangency means this is one time. Horizontal tangency means how many time it touches the horizontal axis. That's all. So this is 1.5. If this is a full circle means you can take it as a 1 more. But it is a half circle means you can take like 1 plus 1 by 2. So answer will be 1 by 3 by 2. The answer will be 2 by 3. So you already have fx. So fy will be equal to what? Fx divided by 2 into 3. Correct na? So it will be 3 into 10 divided by 2. So it will be 15 hertz. So fy will be what, my dears? 15 hertz. fy will be what? 15 hertz. Okay. So you write here for full circle tangency is equal to 1. For half circle tangency will be 1 by 2. That's all. Okay. Is it clear, my dears? Is it clear? Write another question. this planar equal you can expect. So suppose fx equal to 5 hertz, then Fi equal to what? Fi equal to what? See the question. We have the basic equation like Fx by Fi is equal to vertical tangency divided by horizontal tangency. Okay, frequency and vertical will be opposite now. Fx correspond to Vt. Okay, in that way you can remember the equation. Fx by Fi is equal to Vt divided by vertical tangency by horizontal. So what is the vertical tangency, my dear? Only one time the circle touches the vertical line, correct? You don't go for the second cycle because it doesn't touch the vertical line now. It is only one time it touches the vertical axis, that is the y-axis. So it will be 1 divided by how many times it touches, the circle touches the horizontal axis. 1, 2, 3, 4. This 1 by 4. So Fx will be given as 5. So Fi will be equal to what it is, my dear? Fx by 4. It will be equal to 4 into 5. 20 hertz. This is how you have to solve the question. This is how you have to solve the question. Okay? Write another question. Write another question. Okay? Many questions you may expect from this. Many questions you may expect from this, my dears. You can see in this manner also. You can see in this manner also. Yes, this manner also. So this is x and this is y axis. So Fx, here Fx is equal to 10 hertz. Then what is Fy? The question. Then what is Fy? This is the question. This is the question. How can we solve, my dears? How can we solve? How can we solve? So again we have the basic equation as Fx by Fy is equal to vertical tangency divided by horizontal tangency. So vertical tangency means how many times it touches the vertical line. See, the circle touches the vertical line, is 1 here, another here. So it is 2 divided by horizontal line. See very carefully. Very carefully you can see this. The circle touches here, it's 1. So 1, 2, 3, 4. Correct na? This circle is 4. Then this circle also touches 5. This also 6. So 2 by 6. Is it clear, my dears? This is considered as a circle, my dear, and this is also considered as a circle. So this is one part and this part of the circle is that. So you may have a confusion that this you can take it as a single one. No, this is a part will be cut here of this portion. For a part will be cut here for this portion. So 1, 2 you have to take. So, but this is single a circle, right? This is single circle. So 1, 2, 3, 4, 5, 6. Is it clear? Is it clear? So you have Fx equal to 10 hertz. So Fi will be definitely Fx into 6 by 2. So it will be 30 hertz. Is it clear? Is it clear, my dears? Okay. And one more question you can do this. Okay. Listen. So what is Fx by Fi? Simply Fx by Fi is what here? Fx means what? Vertical tangency by horizontal tangency, which is equal to, what is vertical tangency here, my dears? How many times it touches the vertical line? See, 1, 2 times it touches, but a half circle is touching. So you can take vertical tangency as 1. 2 times it touches, my dears, but we want to take it as simply a half side, only 1. Correct? Correct? Yes. One, two, yes, correct. Same circle is touching now, so you can take 1, 2. Yes, so it is 1. And what is horizontal tangency means? How many times the circle touches the horizontal line? See, this is touching 1. But you can't take it as full, so it will be half plus 1, 2, 3 and again half. So it will be 1 by 4. Yes. Yes, BH is equal to 4. 1 by 2 na? 1 by 2. Is it clear, my dear? Is it clear? So this is all about the what? Vertical and horizontal tangencies and the Lissajous pattern. Okay. Normally, not this much complicated things will not be asked. In a simple question like that, no, that will be asked. And options also you can easily crack. Okay, from looking options also you can easily crack. If there are any doubt, please mention in the comment section, my dears. Okay. Okay, that's all about the concept. Yes. That's all about the concept. Okay, so what's the time now? Okay, so that's all for today, my dears. Let's meet again tomorrow with a new session. So until then, bye.